We're going to do a scope calibration. We're going to try and find out how accurate the Rigol DC power supply is compared to the oscilloscope. So this is going to be voltage. This is the yellow channel, and voltage goes directly across there. Now on the Rigol, the voltage is set to 10 times on the voltage probe. So probe on 10 times, DC coupling, and 10 times on the probe as well. Now this is going to be the current, which will be the blue. Okay, the probe is set on 1 times. That's the current. Now the current is across the resistor here, and the resistor is a 0.1 ohm resistor, metal strip resistor. Okay, so the probe is set to 1 times, the channel is set to 10 times on DC coupling. So we're going to plug the power supply in. Okay, so we have a 5 volt supply coming through, so if we switch it on, well, to be honest, we've got a set 5 volt, don't we? Next one up. There we go, 5 volts. We have some light on the light there. Okay, according to our meter here, we're drawing 4.4 watts. If we have a look at our oscilloscope, we're drawing 4.9 watts on average. So again, our blue probe here is set to amps. The yellow probe set to volts. Math is A times B, so channel A times channel B, and this is the output we are seeing through the measurement block here. The measurement block goes through obviously to the capacitor bank and then out to our load. So what we're doing is we're calibrating. We're finding out what the scope is measuring versus what the Rigol power supply is measuring, and they're not too far out. So they're roughly about 0.5 of a watt out, which is actually a reasonable margin, but if you were to go into percentage, it's not too bad. Now on average over time, over a greater time, the oscilloscope may give a better reading, and we can try that. The Rigol oscilloscopes are fantastic, but you can see there's a fair bit of delay in there, and I'm extremely unhappy with the delay. It's so slow, it's just painful. We've gone 5 seconds there, that's probably too much. Let's go 1 second. So it should be drawing a waveform across the scope every 1 second. Every 1 second, so our average, the average wattage coming through that we're measuring, 4.97. VRMS, if you were to read that, which I don't use because it's DC, there's no point using VRMS. It's not accurate when you're using DC. So the average is 4.95. The VRMS bounces about, it's about 4.97, 4.96. So it jumps around a little bit. Not that it should, because there's no power coming back, it's just noise on the line. So all in all, our meter is pretty good. We have a reasonably accurate reading over here for a DC power supply. We will continue on with our experiment. As I say, this is just a calibration, just to see what the oscilloscope is going to read compared to what the DC power supply is going to read.